Okay, so welcome everybody. Thank you for coming again. I'm Lorenzo Speranzoni from LARUS. Today I'm going to present a couple of works that we did in the last few months. So we realized an open source connector with Couchbase, and I want to spend some time explaining how about the architecture and the ideas behind the connector, which is a typical example of polyglot persistence. And of course, I'd like to talk about the new JDBC driver that we just implemented for the Neo4j 3.0, which of course use the BOLT protocol to speed up performances. So I'm Lorenzo Speranzoni, as I said. I'm from LARUS Business Automation. We are a proud sponsor of today's event. We are a partner since 2013 of Neo4j, and we provide consultancies, training. We are based in Venice, and by the way, this is the Venice we know. In reality, not this one for George Clooney wedding. You can imagine the gondoliere over there. So that's the Venice we love. We started in 2011 when Neo4j was in 1.x release. So we have a quite long story around Neo4j. And at that time we were working for a retail company, and the idea was to arrange all the articles and clusters of articles inside the graph database. It was the time when we met Jim Weber for the first time, and we started spiking about that. Then in 2013 we decided to become a solution partner for Neo4j, and last year we started becoming certified professional Neo4j partner, so we can deliver with a certified expertise. And this year, when we met in early January, talking about what we could present here at GraphConnect, we decided about that two projects that I told you before. So we started contributing on some interesting projects around Neo4j. In Italy, we are working for these guys. We run an interesting POC for Barclays around, of course, fraud detection. Served is an early adopter in Italy for Neo4j. They own the entire Italian business network inside a graph, so they can understand who's the real owner of the company by surfing on the graph. Veneto Bank, that they have a speech today, right? A couple of speech after this, my own one, so please come, and they will explain better than me what we did together. And the Catholic University of Milan, which is using or better adopting Neo4j to map the entire scientific publication inside Neo4j, and then the researcher can use the graph database to run a recommendation engine as a recommendation engine where to identify proper publication that they are interested in during their research. So what about the Couchbase connector? The two most important key factors that we tried to introduce is the bidirectionality, and that the connector is also configurable. We were wondering about how to, let's say, to transform. The problem is about how to transform the JSON into a graph, no? So there are already papers about that, especially William Leon from Neo4j already did it for MongoDB, which is another document database. So we stole lots of his ideas and we put inside this. But then we were wondering about how to evolve the configuration. So let me try to explain you. We took this case study. So the Spotify has an interesting set of API, like most of these companies. So we took this as a model. This is a typical album representation as a JSON, no? Where we have tracks. We have 11 tracks in this album. And here you have all the information about one single track, and this is an array, no? So the idea is we started with this question: how can we convert this JSON into a graph? So as I told you, please also join William Leon in the next session because he's going to talk a lot about polyglot persistence, like this argument. So in general, the strategy, the basic strategy is this one. For primitive attributes like strings, sorry, there should be a light, okay. No. And for primitive attributes like strings or numbers, the general idea is, of course, to copy them inside the node. So if we have an album JSON, we create an album node, and all the primitive types, as I said, becomes all properties inside the node. And this is the same for array of primitive attributes. So we can reuse the same idea inside a property, no? which can be, of course, another time an array of strings. Things become a bit more complex when you have a nested object, no? Like, for example, the artist. So the general idea is that objects that are nested inside becomes connected nodes. So we have the album, and we create a relationship, and we copy all the artist's information with the same strategy inside another node. Then we can also have array of objects as attributes, and this, of course, becomes items in the form of a list of connected nodes. So the JSON, the general idea is that a JSON becomes an album with an artist. The album has tracks, and the tracks are those 11. The architecture is based on 4 main components, which are this one. We have a Couchbase listener, which listens about documents that are changed inside or newly created documents inside the Couchbase. And this listener transfers the document, the mutated document inside the graph through a Neo4j server extension, which is a JSON loader that you could reuse by itself. I mean, through this server extension, you could load JSON coming from every source. So we separated the 2 projects, and now you can find in our own repository in GitHub, you can find this single project, which is used, of course, to drive the information coming from Couchbase inside Neo4j. Then we have another server extension, which is another time a mutation listener that looks for nodes and relationships that are changed. When we observe that some nodes and relationship are changed and are related to some documents, we reconstruct on the opposite side the JSON, and we transfer it through the Couchbase software development kit tools. So there's a Java API that you can use to populate the Couchbase back. I'll go faster here. Of course, I don't want to bore you with this code, but the idea is that we have an event which wraps a message. Then we filter this kind of event because we are just interested in mutation messages. Those are all classes coming from the software development kit that I mentioned before. And then we implement an event handler that accepts, of course, only mutation event, and we send through our remote Neo4j transformer, we send the document to Neo4j, to the JSON loader. And to register the listener, we have to implement a disruptor where we attach, of course, our event handler, and then we start the disruptor. So it starts listening what's happening inside Couchbase and send all the mutated documents to Neo4j. The JSON loader, I will talk later, is also configurable. So this is the interesting thing that we try to do as a new feature. And in future, we would like also to introduce the store procedure that Emil introduced today with the Neo4j 3.0 version. So we have enriched the original content, the JSON we are interested, with some more information. We provide a mapping strategy, so we train the translator in a specific, with a specific approach, and we add a domain descriptor, a set of domain descriptor to instruct the JSON loader. Of course, there's a REST API that published a connector that accept the JSON that we have just provided, And we have a transformer that adopts the strategy that we have. It translates the JSON document into a cipher statement, which is then executed inside the transaction. Okay, let's keep some data. Now, this is the opposite. The mutation listener is implemented as a Neo4j transaction event handler. And when a commit happens, after a commit happens, so the state of the Neo4j is changed, we reconstruct, we build the JSON document through some queries and so on, and we send back through a Couchbase JSON loader, we send back the JSON that are mutated. Those are Couchbase classes. We attach to the cluster on the specific bucket, and then we run an upsert, which is used to transfer, to update, if not exist, the JSON document. So this is the idea of having these four components in the architecture. But how about the domain? Now the question is, how can we instruct the domain, or better, the component, the JSON loader, about how our business domain is configured? So we wanted to find a way to say, okay, we have album, and album is written by an artist, abstracts inside, no? So we wanted to instruct the JSON loader with this information, which are fundamental, of course, when we try to manage the domain inside the Neo4j. No? So we observed that inside Neo4j, inside the JSON document from Spotify, there was some interesting information, because of course, even if in a document database information are aggregated, they need to find a way to identify an album. No? So they, of course, have an attribute inside, which is a universal ID that identifies the album, that identifies the single track, and they have also a type. So the idea was to reuse or to use this ID to find in a unique way to find the nodes that we already have inside the database, inside Neo4j, of course. So using those ID, we can reuse effectively the nodes that we have already eventually created. And the type could be used to decide the label's name. So we introduced a way to describe the domain. We added this JSON descriptor. So, for example, the album domain object is uniquely identified by the ID property, and you can take the label to use for albums inside the type attribute. So with this set of information, we enrich the original JSON document by saying, okay, this is an album, the type. This is the unique key that the Couchbase pretends when you store a new document inside the Couchbase. We provide the JSON mapping strategy, which is in this case a domain-driven strategy, and then we send the descriptor those one. So the resulting query that we create, a bit more enlarged. The resulting query that we create, the transformer that receives the JSON document and that make use of the JSON descriptor, translate the JSON inside into a big statement, a big cipher statement. This is a simple part. Merge album ID, because we told the JSON loader that the ID is the unique key, and then we have the set of information that are updated for this node. So the resulting graph is this one. We have the Joshua Tree album, which is written by U2. We have 11 tracks. Those are the tracks where the seat has no name and so on. Okay. And the interesting thing is that through the domain descriptor, we can effectively make use of reuse, of some nodes inside your graph, so that you can get a real benefit, as I wrote, from a relationship. Because if you create different nodes every time you load a JSON, you cannot make use of a relationship to inspect and to inquiry, for example, to build a recommendation engine on top of this. No? So we needed to find a way to uniquely identify things inside Neo4j. And the second work we did, which is really interesting today, because as you know, we are now in 3.0 version, and we have a great new super fast protocol, which is named Bolt. That Amy is talking about this morning. So we started discussing about contributing here. We have community drivers. So we did one of these drivers. Of course, as a Java company, we have this expertise, so it became quite natural to start working on a standard JDBC interface, because the point is lots of applications pretend to talk to Neo4j through a JDBC standard driver. So even if this is the team, we have Stefan and Michael Hunger from Neo4j that coordinated us in the development. We have Ralph, is a friend from Germany that also helped add in all the test part. Benoit from Neo4j that is working on the HTTP protocol. The key aspect of this, many thanks to those guys, of course. Without them, we couldn't have literally done anything. So the key aspect of the driver are those ones. Of course, make use of the new Bolt protocol. It has a modular design, because the current implementation is not so fast, but also is quite heavy in terms of megabyte that you import inside your application, because all these ways you can interact with the database are all merged into only one module. So it's quite heavy. The idea is that you can decide which way to interact with the Neo4j, and you import just the specific part that you are interested in according to the application that you are developing. Of course, it's heavily tested, and it's focused on performance, because we wanted to improve the 2.0 version, the current version that you have in the Neo4j contrib repository. The Bolt implementation is just a wrapper. In the end, last week, the Neo4j team produced a Java driver, which is the Bolt implementation of the driver. This is the page where you can find it. So the Bolt module is just a wrapper of the Java driver, which is in release 1 version. So now it's official. While we were working on it, it wasn't still on milestone. So we need to finish some things. So a Java application can talk with Neo4j through a standard JDBC driver, making use of the Bolt module in that way. And then, as I said, we have all the other modules. In particular, those ones will be implemented in future months for retrocompatibility, because Bolt comes just with Neo4j 3.0. So we need also to be retrocompatible with the previous version of Neo4j, because if, of course, having production a 2.0 version, you need to be retrocompatible. So we will work on also this stuff. But then the memory version could be used to even improve performance again, and so on. As I said, it is heavily tested. We have for 60 classes, we have almost 300 unit tests and 50 integration tests. So every single piece of code that we have implemented have lots of testing on top, because our idea is that you can use it in your production environment. So we want to provide you something that is really have a strong code coverage. And as I said, it is focused on performance. Those are great performances if we look at the CVS file that we imported compared to what Emil said this morning. But it's a pentaho problem. Sorry for that. Just focus on the performance. The old driver takes 30 minutes to import those lines, while the new one is taking more or less half, so 17 minutes. So we are quite happy about performance also. We still have to do some performance tests. We are just starting, because we are still focused on completing the implementation, of course. We already tested with some of these tools, and this is the good news about using the JDBC, no? Standard interface, because most of the application for IT and products for BI and so on that you probably use, as I said, pretend that you talk with a standard interface, which is the JDBC. So we started with pentaho, because we have a partner that is using heavily pentaho, but is also really interested in using Neo4j. So we started to test with the kettle ETL component of pentaho, and it is working. We are working on qlik, which is probably one of your most favorite tool for BI. And this is the part for developers. So you have the data visualizer in Eclipse and all the other tools for DB visualization for programmers. Talend is, of course, an enterprise service bus that also can use JDBC to communicate. There's just one slide of code because it is standard. So we load the driver. We just load the driver. Then we connect through an URL which is defined according to the protocol. Then we create a statement. We execute a query, match user, return and .name, and then we cycle on the result set. In this case, just to print the name of all the user nodes, and then we close the connection. This is the minimal viable snippets for using our driver. This is more or less the release plan. Today at GraphConnect we are announcing the milestone 3, which has the bot protocol. In milestone 4 we will introduce the HTTP protocol and the callable statement, because we want to make use of stored procedure, which was also announced this morning. Then we will work on fully retrocompatible implementation for milestone file, and more or less in early autumn we would like to go with a production-ready version of the software. That will be, of course, probably moved to the Neo4j contributor repository. So have fun with us, please. We need help. Lots of work and funny things to do. Those are the coordinates of our repository, LARUS BA. This is the team. They are in the room. So if you want to learn about this great thing that they did, please meet them and talk with them. Mauro, Marco, Alberto, and Gianmarco, thanks for your hard work. Thank you so much.